Welcome to the hidden layer. Today we're diving into something that is so frustrating about AI. It's this one problem that can make the most brilliant, powerful models feel, well, kind of useless.
I mean, has this ever happened to you? You spend like a solid hour with an AI, you're mapping out this amazing project, and then you come back the next day, and it has no idea what you're talking about. Total amnesia. It's like you're talking to this genius expert who also happens to have the memory of a goldfish. And that right there is the amnesic AI problem. It's the big thing holding us back from having AI agents that are actually useful over the long haul.
So the whole issue really just boils down to this. Right now, AI memory is kind of like what you see on the left, this messy, disorganized cloud of facts. They're all just floating around, completely disconnected. But what we actually need for real understanding is what's on the right, a clean, connected story where every piece of information has context and relates to everything else. Okay, let's dive in. In just the next 5 minutes, we are going to unpack a brand new framework called StructMem, and it might just solve this whole memory problem for good. Now, for all of you applied AI engineers out there, you definitely want to stick around. We're going to give you 5 solid principles you could start using in your agents, like today. And I'll be sharing a really clever trick later on that makes these memory systems way, way more efficient. All right, so before we can really appreciate why StructMem is such a game changer, we have to understand why the systems we have now just aren't cutting it. It all really comes down to this big trade-off between two different and honestly pretty flawed approaches. So on one side, you've got what's called flat memory. Think vector databases. They're super fast, right? Great for just finding similar stuff. But the big problem is they completely lose the context, the story that connects all the facts. And that leads to this lost in the middle issue where really important details just get buried. Then, on the other side, you have graph memory, knowledge graphs. Now, these are amazing at capturing how things relate to each other. The catch? They're crazy expensive. They're slow, and they're honestly pretty fragile and easy to mess up. It's this classic dilemma. Do you want speed or do you want intelligence? And this, right here, is the absolute heart of the problem. We've just been using the wrong building block for memory. Trying to store memories as just isolated facts or these really rigid subject-verb-object things, it's like trying to understand a whole movie by just looking at a handful of random screenshots. You completely lose the plot. And that is exactly where StructMem enters the picture. It's this new framework that offers a super elegant solution, a way to get the best of both worlds without having to make those painful trade-offs. Now check this out. The whole thing hinges on this one really powerful idea from the paper. It says that the basic unit of memory shouldn't just be a fact, it should be an event. And what's an event? It's something that's locked in time and captures all the relationships within that moment. You can think of it like a complete contextual snapshot. So the really crucial innovation here is that StructMem is a hierarchical system. What does that mean? It means it organizes memories in layers. So it doesn't just remember what happened, it also preserves how all these different events are connected to each other across time. And the best part? It does all this without needing some fragile, rigid structure you have to define beforehand. Okay, but how does this actually work? Let's pop the hood and take a look at how StructMem actually builds this amazing, structured, story-like memory. So the whole architecture really has 2 main levels. Down at the bottom, you have what's called event-level binding. This part is all about capturing single moments in super rich detail. And then at the top, you've got cross-event consolidation. And this is where the real magic happens. It's where all those individual moments get woven together into a coherent story. So let's break down that first level, event-level binding. For every little piece of a conversation, StructMem does this thing called a dual perspective extraction. It basically asks the language model 2 questions. First, what are the raw facts here? And second, what are the relationships between those facts? The cause and effect, the dynamics between people. Then, and this is so important, it does something called temporal anchoring. It slaps a precise timestamp on every single one of those facts and relationships. Why does that matter? Well, it makes the memory completely verifiable. The AI can literally trace any conclusion it makes back to the exact moment it learned that piece of information. And that's absolutely crucial if you want to build AI systems we can actually trust. All right, now for level 2. And remember that clever trick I promised you at the beginning? This is it. Instead of trying to update some massive, complicated graph every single time a new message comes in, StructMem does something way, way smarter. Every once in a while, it just searches its memory for related events, Like maybe it pulls up all the times you've talked about Project Phoenix. And here's the key. It doesn't just summarize them. No, it synthesizes them. It creates a totally new, higher-level memory, something that might say, okay, it looks like the user is getting more and more worried about the deadline for Project Phoenix. You see, it's not just collecting facts, it's actually building the story.
Okay, so the theory sounds amazing, right? But what about the actual results? I mean, does it work? Well, this is where it gets seriously impressive, especially for any of you out there who are actually building these things in the real world.
Just take a look at this. When you compare it to those traditional graph-based memory systems, StructMem isn't just a little bit better. It's a whole different league. It massively cuts down on token use and how long it takes to run. And what does that mean in the real world? It means lower costs and much faster responses for the user.
And the secret sauce behind all this efficiency is that buffered consolidation we were just talking about. Because it processes updates in batches instead of one by one by one, it just slashes the number of API calls and all the heavy lifting your computer has to do. It's just a ridiculously smart way to build a complex, structured memory without paying that performance penalty on every single interaction.
Okay, so for all my engineers watching, let's get practical. Here are the 5 big takeaways you can use right now. 1. Start thinking in events, not just isolated facts. 2. Use that dual perspective prompting strategy to pull out both the what and the how. 3. Go for that periodic batched consolidation. Your servers and your wallet will thank you. 4, and this one is huge for building verifiable agents, make sure you anchor every single piece of data to a timestamp. And finally, number 5, stop just summarizing, start synthesizing. That's where you go from just spitting back information to actually generating new insights. That's where the real intelligence is.
And look, if you're worried about the AI just, making stuff up, the paper has some really good news on that front. They ran a fidelity study and found the average hallucination rate, that's when the model just invents facts out of thin air, was only 2.36%. That's super low. And it makes sense, right? Because every single memory is tied back to a specific thing that was said at a specific time. The whole system stays grounded in reality.
Now, of course, no system is perfect, and the authors are really upfront about the current limitations. For one, the quality of the memory you get is highly dependent on how good your prompts are. Garbage in, garbage out. And right now, there's no built-in way for it to update or maybe even forget old memories when new conflicting information shows up. So these are definitely some great areas for future research to tackle. So I want to leave you with this final thought. We're on the verge of moving from AIs that can just recall random facts to AIs that can actually understand the narrative, the story of our interactions with them. So the big question is, what new possibilities open up when our digital assistants can finally remember the story? Thanks for watching The Hidden Layer.